Okay, this is the first video in consumer maths. And to start off, we're just going to have a look at fractions, decimals, and percents. So this video is just part one, where I'm going to talk about what these are, how they're related to each other, and how to convert between them, because it's going to be quite a common thing coming up a lot in this consumer unit. Okay, so let's start with fractions. So essentially, I'm just going to use a couple of letters here. Don't be perturbed. A over B. Fractions take this form. So there's two numbers in the fraction, but it's essentially just one value. In general, we sort of say that A is going to be less than B, and in that case, in our number line, if A is less than B, then this fraction is going to be somewhere between 0 and 1. A can be bigger than B, but it just means we've got a whole number added on plus something in this interval. And strictly speaking, a fraction is like a proportion of something. So the classic example, let's say a pizza. Got a whole pizza, and we can, so this is half and half. So essentially the bottom number is how many pieces the thing is cut into, and the top number is how many of those pieces are represented by everything that we have. So for example, if we just get rid of that, if we cut the pizza into 8 pieces, and then we eat 3 of the pieces of pizza, so all we really have left is this bit. Those bits are gone. Let's rub that out. So essentially the pizza was cut into 8, and now we have 1, 2, 3, 4, 5 eighths of the pizza. Now, strictly speaking, that's essentially what a fraction is. We're cutting 1 into this many pieces, and we have this many of them. Now, other numbers are written as fractions. Ratios are the main other type of number you see written as a fraction. And the main difference is, strictly speaking, a fraction should have whole numbers at the top and the bottom, but a ratio doesn't have to. It can have anything at the top and anything at the bottom. Something else to be aware of is, in the form that a fraction is, it essentially means this equals A divided by B. So this line, it's kind of like the divide symbol. So in general, just as we're solving problems, I might say, I don't know, 200, and then divided by 10, and I would write it divided by 10 like that, which equals, the tens, 20. Okay, I think that's enough of the basic preliminaries. It's probably worth talking about equivalent fractions as well. So for example, let's say we had half a pizza. We can cut this into smaller pieces. So 1/2. Oh, let's just draw it again. This equals, so there's our half a pizza, but we're going to cut that in half. So that's 2/4. And we can cut each of these in half again. And we've got 1, 2, 3, 4 of those bits, but if we had the whole pizza, it would be 8 bits altogether. So these are all what we call equivalent fractions. And we call them equivalent because we still have half a pizza in each case, but the numbers that we're using to represent the proportion is dependent on how small the pieces are cut. That's essentially it. So with equivalent fractions, it's probably worth talking about multiplying two fractions together. So, for example, if we have 1 on 2 and we multiply that by 3 on 4, just as a random example, this essentially equals, we multiply the top numbers, 1 times 3 over, and we multiply the bottom numbers. So they just sort of go together in a multiplication. So this would be 3 over 8. So with multiplying, we just multiply the tops together, we multiply the bottoms together, and we keep it as a fraction. Something you may remember from, well, a long time ago. If we're dividing by a fraction, let's just use the same numbers. So if we're dividing by 3/4, the strategy with that is not the first number, but the thing we're dividing by. We turn it upside down, so the 4 would come to the top, the 3 would come to the bottom, and then it turns into a multiply. So this is multiplied by 4 over 3. And multiply that out. So now I've got multiplying out of the way, as far as equivalent fractions go, it's worth mentioning that when you multiply, well, this is going to sound silly, but when you multiply something by 1, 7 multiplied by 1, it equals 7. Now, when we come to fractions, we can represent a fraction using any numbers we like, but it is essentially 1. Because if I said, well, 2, how many 2s? That equals 1. But this is also can be written as a fraction 2 over 2. When we've got a fraction with the same number on the top and the bottom, then it's equal to 1. So 3 equals 4 over 4 equals 17 over 17, and they're all equal to 1. And the reason this is useful is because in this equivalent fraction example, we can generate these different numbers simply by multiplying by 1, but it's going to be a fraction, 1 represented as a fraction. So just using this example at the top, we started with half a pizza, and then we cut it in 2, so we're essentially multiplying. If we look at 1 turns into 2 and 2 turns into 4, we're essentially multiplying the top and bottom by 2. So really this is half for pizza, multiplied by 1, and it comes out 1 multiplied by 2 is 2, 2 multiplied by 2 is 4, which is the fraction we had up there. If we started with here and we just cut it straight into that, we'd multiply, the 1 turns into a 4, the 2 turns into an 8, and we're multiplying by 4 over 4. So these are both 1s, and we end up with 4 8s. Okay, so equivalent fractions. Now remember, let's get rid of that. So remember I said we're going to be moving on to decimals. Remember I said that a fraction, let's just write it as a over b again, equals a divided by b. Now if you type this into a calculator, a divided by b, it turns it into a decimal, and you will get the decimal representation. Okay, so now I'm going to talk a little bit about decimals. Actually, I might just leave that there. Okay, so decimals. I'm going to start with, let's say, 3, 4, 5, 7, 8. Let's just say that number with a decimal point. Now there's a little bit of number theory in here, but just to sort of explain what's going on. So the numbers, the whole numbers, we understand that this is the units. This number is the tens, hundreds, and it keeps going that way. So essentially what that means is the 3 actually represents, in this number, 3 times 100. Yep. I could write that a bit better. So the 3 is 300. Put that in there, which is 3 times. I'm going to put this in brackets, and then I'm just going to write it one more time. Times 10 times 10. Because decimal, the dec, comes from Latin for 10. So we're in a base 10 system. And that really just means that we have 10 different symbols that we write for numbers. So the 3 is actually representing 300 because of the position that it is. 3 times 100. Okay, so the 4 represents 40, which is 4 times 10. And I'm just going to write this again, but it's over here. So as you can see, as we come down to the next position, closer to the decimal point, it's in a different colour. We're essentially, as we come down here, we're dividing by 10. So when we get down to the units, 5 represents 5, nothing remarkable there, which is 5 times 1. So I'm just going to write that like that. In this next thing, I'm going to turn that 1. I'm just going to start with what's in the brackets here and divide by 10. This is 5 times just so that we have this repeating pattern of, we're going to divide by 10 again. Okay, so now that's where our decimal point hits. Just put a little dotted line there. So when we come beyond the decimal point, essentially what's happening is we're going to divide by 10 again here. So really we've got a 1. So this 6, I'm just going to write it 0.6. That's really what the 6 in this position represents, which equals 6 times 0.1. And if we're starting with 1 and we're dividing by 10, I can write that as 6 times 1 on 10. So that we're just dividing by 10 again. So each time we go one step in this direction, we're essentially dividing by 10. So we've got the symbol that represents how many of those, depending on what column it is, how many we've got. So we've got hundreds, tens, units. Now these are tenths. The 7, just quickly do this, I probably won't do the 8. This represents 0.07, which equals 7 times 0.01, which actually equals 7 times 1 on 100. So when I say divide by 10, here's a little sneaky thing. This is the same as, if we look at the 10 as a fraction, 10 over 1, we can turn that upside down, multiplying by 1 on 10. So each time now the number on the denominator is going to get 10 times bigger. So that's basically saying we start with a unit, so that's just one single thing. We chop that into 10, and that's what's represented here. If we chop one of these into 10, it's essentially the same as chopping one of these into 100. I think that's probably the best thing I can say to represent. So as we're moving along, we're dividing or multiplying by 10. If we go this way, we need to multiply by 10. We're starting with 1s, and we go to 10s. 1 times 10 is 10. The next one's 100, hundreds, so 10 times 10 gives us the hundreds. So essentially the point of explaining this is, I'm going to rub this out now. When we multiply or divide a number by some multiple of 10, the actual digits don't change, but the position of the decimal place does. So I think in order to relate decimals and fractions, forget the whole numbers. Really, I'm going to rewrite this number, but I'm going to, let's say, break it apart into its different bits, and I'm going to add them all together. So this bit you'll be familiar with. So we've got 300, and then I'm going to add 40. I'm going to add 5, so that's 345. Then I'm going to add 6/10, and then I'm going to add 7 1/100ths, and then 8 1,000ths. So this is to sort of show how once we get beyond the decimal place, really these numbers are representing fractions with multiples of 10 on the bottom. So I'm hoping that whenever we're multiplying or dividing by any kind of 10, 100, 1,000, you don't need a calculator. You just shift the decimal place wherever it needs to go. Okay, so that leads us into what percents are. So decimals are a way of representing numbers using specific fractions for the parts that are smaller than 1. Right. So now let's have a quick talk about percentages. So let's just put our number line back up here. 1. So a decimal is essentially going, let's just chop this into 1, 2, 3. They're not exactly perfect, but we're chopping that interval into 10 bits. And that's our first decimal place. Our second decimal place is chopping one of these into 10 bits. And then the third decimal place is chopping one of those tiny things into 10 bits. So as we go down the decimal places, we're just adding tiny, tiny, tiny bits. Okay, now, fractions. So there's halfway between 0 and 1. Call that a half. But it's also 1, 2, 3, 4, 5 tenths. So there's another one of those equivalent fractions. So this, I kind of wanted to say that because decimals and fractions, they both inhabit the same space on the number line. Whereas a percent, it's a slightly different way for us to talk about these sort of proportions between 0 and 1. And really, this is decimal fraction. So this is our real number line. This is where numbers actually are. Now a percent takes this little interval, but instead of talking about 0 point this or fractions, we essentially cut the interval from 0 to 1 into 100 pieces, and then we can talk about some proportion of this in terms of how many of those hundredths. So the cent, kind of like dec, cent refers to 100 in Latin. And the way we get there, so in decimal, percent, so this is the symbol. All we do is in red, multiply by 100. So essentially 0.35 as a decimal times that by 100. So we just, this gets 100 times bigger, and because this is a multiple of 10, it's going to move the decimal place 2 spaces because we've got 2 lots of 10, and this becomes 35%. And I think the only reason we sort of have this is because in our vocabulary, the way we talk about numbers, we sort of like to talk in whole numbers. And this is another way to look at these sort of proportions. So to go from a decimal to a percent, we multiply by 100. And to go back the other way, we just do the opposite of this. And so we divide by 100, which really means shifting the decimal place to 2 places in the opposite direction. So let's just use this example, 35%, and then I'm going to divide by 100. And when that happens, the percent sign disappears, and we're moving the decimal place 1, 2. We're going to end up back 0.35. So when we're doing calculations with fractions, decimals, and percents, really we need to use the fraction or the decimal version. The percent doesn't really belong in the number line. It's just a way for us to talk about these smaller numbers using whole numbers in our language. Okay, so now with percents we can sort of talk about proportions of things. So let's try pizza again. 35% would mean if we cut our pizza into 100 pieces, quite small pieces, we'd end up with, let's just say that, 5%. We have that bit, which is a little bit more than a third. Okay, so I'm just going to very quickly go have a recap of how to convert between these 3 different ways to represent proportions. Okay, so it is possible to convert from each of these to each of these, but just sort of go over the ones that we're going to need. So first of all, fraction to decimal. And we said top divided by bottom. That's numerator, denominator. Let's call them the top number and the bottom number. Go from decimal to fraction. If the decimal ends, if it stops like the number 0.5 or 0.25, then it's kind of easy. You just need to convert the decimal part into a whole number, and then we won't really need that. Fraction to percent, easier to go fraction to decimal and then decimal to percent. Decimal to percent was times by 100, and we write the little percent sign. That sort of means hundredths. And percent to decimal going this way, divide by 100, and we lose the percent symbol. To go from a percent to a fraction, this way, I suppose it's a bit of a, because percents are essentially hundredths, we write the percent, percent over 100, so 35% would become 5 hundredths. So that's then have to reduce this to its most simplest form. So we're looking for common factors in the top number and the bottom number. And if there is a common factor, then this is essentially an equivalent fraction for a smaller fraction. Well, not smaller in size, but the numbers are smaller. So in this case, we've got a number 35 ends with a 5. And I know that numbers in the 5 times table end with a 5 or a 0, so I know both these numbers end with a 5. So what I'm going to do is break the top and bottom into something times 5. So 35 over 100 equals 7 times 5 over 20 times 5. So this is essentially 7 over 20 multiplied by 5 over 5, which is 1. So this is 7/20ths. So there's a bit of a process writing it over 100 and then looking for common factors. Fractions and decimals are what we really need for the calculations. Cents are kind of how we come across these values when we're talking about money. Okay, so that's where I'm going to leave it. Hope it hasn't been too long. See you in the next video.